Let's practice balancing some equations. The very first thing you have to do is your atom inventory. And that's where you count how many of each type of element are on each side of your equation. I like to list mine right here under the arrow. So I've got carbon, and on the left I can see I have 1 carbon. And on the right I can see that I also have 1. Next I have hydrogen, and it really doesn't matter what order you put them in. I can see I have 4 hydrogen on the left and 2 hydrogen on the right. And I have oxygen. You can see there are 2 on the left, and I can see there are 3 on the right because I have 2 here plus 1 there. So balancing equation means making sure there are the same number of atoms on the left as on the right. You cannot create or destroy atoms. You can only change the number of atoms by adding coefficients. I put the blank lines in on these examples so you can see where to put those numbers. Right now, there's an understood 1 there. We wouldn't write it if there wasn't at least 1 of them. We can't ever add or change subscripts, like these numbers, because that changes what the element is. So let's look. Our carbon's already balanced, 1 and 1, but we have 4 hydrogen on the left, but only 2 on the right. So we need to make this water give us 4 hydrogen. Each water molecule gives us 2. So if we put a 2 here, then 2 times 2 gives us 4 hydrogen. It also changes our oxygen. You always have to make sure your inventory is correct. So now I have 2 oxygen here and 2 oxygen here to give me 4. So now my carbon and my hydrogen are balanced, 1 and 1 and 4 and 4, but I need to fix my oxygen. I only have 2 on the left and I need there to be 4. So if I put a 2 here, and 2 times 2 gives me 4 oxygen. And I can see with my inventory that my equation is balanced. Please be aware that this inventory is for you to figure the problem out. I'm not grading it. I'm grading these coefficients. I'm grading that you tell me 1 CH4, 2 oxygens make 1 CO2 and 2 waters. Let's try another example. So the first thing we do is our atom inventory. And we have potassium, and on the left we have 3, and on the right we have 1. The next is phosphorus, but you should know that PO4 is a polyatomic ion. And since it stays PO4 with no changes on the right, we can just count it as one thing because it behaves as one thing in this reaction. So since that makes my counting much easier, I am going to count how many PO4s I have. And on the left, I only have 1. Don't tell me you have 4 because you don't. You have 4 oxygens. You have 1 PO4. And on the right, you also have 1. Count our hydrogens. On the left, there's 1, and on the right, we have 3. And finally, we've got chlorine. We have 1 on the left and 1 on the right. So we can see that hydrogen and potassium are the ones that need to be fixed. So we have 3 potassium on the left and only 1 on the right. So in order to make there be 3, we're going to put a 3 here. This changes our potassium. It also changes our chlorine. We have to make sure our inventory is correct all the time. So now our hydrogen, I need there to be 3 on the left. So 3 times the understood 1 gives you 3 and 3 chlorines. And it took care of itself. Now we have everything balanced. For most problems, they should work out fairly quickly in a few steps. So if they don't, then you need to go back and check your inventory because you probably miscounted something somewhere. Let's try one more example. So let's do our inventory. we have 2 carbon to the left and 1 carbon to the right. We have 6 hydrogen to the left and 2 to the right. And for oxygen, we have 2 to the left and 3 to the right. I will let you know that because oxygen is in more than one place, you should leave it for last. Anytime an element shows up in 2 places, it should be the last thing you balance. So let's make our carbon be balanced. In order to have 2 over here, we're going to give it a coefficient of 2. That means that we now have 2 times 2 is 4 plus 1 is 5 oxygen. And let's fix our hydrogen. We need to have 6. So we're going to put a 3 because 3 times 2 gives me 6. Let's fix my oxygen again. I have 4 here plus 3 here gives me 7. A lot of you would get this far and then get stuck because I have O2 over here. And no whole number times 2 will give me 7. And we can only balance using whole numbers. But I will show you a trick. We can use a half number as a placeholder to find the ratio, and then we can get it to a whole number ratio. So let's think, what times 2 will give me 7? We can have 3.5. So 3.5 times 2 gives me 7. Now it's balanced, but it's not a whole number ratio. So to get the final answer, what you have to do is multiply all of your coefficients by 2. You can't forget this one here. It's an understood 1. So 1 times 2 gives me 2. Now we just have twice as many of everything. It gives me 7, 4, and 6. And that's our lowest whole number ratio. This little half number trick can make them a lot easier, but if it doesn't for you, if it just makes it harder for you, then just don't do it. You can get around it and get the right answer the other ways. It just takes longer. The only way to get better at balancing is to practice, so go practice.